Agriculture is 10,000 years old, but science in agriculture is really only a century old. And so if we look at corn, the development of hybrids, that work was done in the late 1800s, and it wasn't until the 1930s that hybrid corn was first planted in Minnesota. Well, it just so happens that I was born in 1935, and so this curve of yield is sort of my lifespan, and I've been very much involved in the teaching and the research and observing the transformation in agriculture and this growth in productivity. Look at this. In 1935, our yields were 33 bushel to the acre for corn. In 2010, we had a state average of 174 bushel to the acre. So that we have increased 150 bushel over that time span. This yield increase is the culmination of a lot of science and a lot of technology. It's not all genetics and it's not all machinery, and it's not all fertility. Because if you look at it, this was the native fertility and native production. 33, 35 bushel to the acre. This yield increase didn't come about just because of fertilizer, nor did it come about just because of hybrids and improved genetics. It was the combination of everything. I did a study some years ago trying to sort out where this yield increase came from. And yes, genetics, hybrid vigor, genetic gain that the plant breeders do by selecting for yield, for disease resistance, and then of course, and more recently, biotechnology, also a part of plant breeding. Those collectively in recent years account for just a little over 50% of the gain. But the other half of the gain is all kinds of management. Row spacings. We went from 42-inch rows to under 30-inch rows. Tillage. We went from only spring tillage to fall plowing, fall tillage, so that we could plant earlier. We went from hill checking to solid drilling. That spaced the plants more uniformly. We went to earlier date of planting. Historically, back in this time period, we planted on May 20th. That was the average date of planting. In recent years, our average date of planting has been right around the 2nd to 3rd of May, with best farmers planting as early as April 20th. Rotations have changed. Not necessarily for the best, because we don't have as much alfalfa, but we have a lot of legume in the form of soybeans in the rotation. Plants per acre. Back in this time period, the farmers planted 12 to 14,000 plants per acre. Our farmers out here today are in the 32 to 38,000 plants per acre. Weed control came in after World War II, 1950s, 2,4-D became available, and from that, all of the myriad of different herbicides became available. And then, of course, fertilizers. Manure was a historic base of fertilizer. It didn't provide enough nitrogen. And so, post-World War II, the availability of cheap synthetic nitrogen fertilizer resulted in significant increases in the amount of nitrogen being applied, and the combination of all of those things are now giving us the kind of yield increases that we see. Now, in the case of soybeans, notice two things. One, the timeline is not as long as it is in the case of corn, because soybeans did not become major crop in Minnesota until late in the 1930s. Really, World War II was what made soybeans a major crop in Minnesota. The yield increase, not nearly as steep, and part of that is because there are more plant breeders working on corn than all other crops combined. All other crops combined. So the genetic improvement is greater in corn than it is in soybeans. The other part is you don't have a nitrogen kick that we got here. Soybeans fix their own nitrogen. So putting on more nitrogen doesn't help. So the big benefits in here have been the row spacing. Going to narrow rows has helped soybeans. Actually, reducing planting rates is helping soybeans. Getting better quality seed and precision planting has helped improve yields compared to what we planted back in the early years. What about the future? That's a great question. It's one that I'm very concerned about. We have a lot of private investment in the breeding and genetics area, but we have almost no investment in all of the rest of the cultural practices. Historically, that was state funded. Companies can't make money selling row spacing or selling data planting. We need more research to complement. But the future very clearly involves biotechnology. Finding those genes that protect the plants against insects and diseases, that protect the plants against the extremes of weather and climate, and finding the yield genes that actually increase as opposed to just protect. Because if we're going to increase these yields, it's twofold. One, protecting against the things that detract from yield, insects, disease, drought, etc. And then the other is the genes that actually put more seeds in the pod or kernels on the cob. The question of feeding the world really is a question that is challenging to all of humankind, and especially to agriculture. Because if we look at where we are today versus what would be needed to feed the population that's projected for 2050, we would have to go from the roughly 175 bushels to the 350 bushels by 2050. In order to accomplish that, we need the support of the public to invest in research, and we need the support of the private sector to identify those areas that they most effectively can develop the technologies and make that available to the farmers and the producers to meet the needs of a growing world population.